we're doing section 8.1, adding and subtracting polynomials. And today you're going to classify, add, and subtract polynomials. Okay? You can use polynomials to form larger expressions. You can use monomials to form larger expressions called polynomials. Polynomials can be added and subtracted. Now, monomial, what does mono mean? 1, right? So that's like 2x, 3, 2xy, okay? That is what a monomial. When you put those together, those monomials, when you put them together, strung along by addition and subtraction, then they become polynomials. Polynomial, poly means many. So when you put many of them together, bless you, that forms a polynomial, okay, for you. So a monomial is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. Whole number exponents. So for example, we have, like we said a real number 3. That could be a monomial. Or 3x could be a monomial, okay? Or 2xy could be a monomial. Or AB, or A. Those are all monomials, okay? Another one here, let's do, let's just do a squared, whole number exponent, okay? Meaning that you cannot have a fraction or a decimal as an exponent, okay? Now the degree of a monomial is the sum of the exponents of its variables. The sum of the exponents of its variables. So in this, the 2xy, the variables are x and y, right? 2xy. The variables are x and y. And what are the exponents for each of those? 1. That's x to the first. That's y to the first. So the degree of 2xy is the sum of its exponent of the exponents of its variables. So we just add 1 plus 2. So 2xy is a monomial to the degree 2. Is everybody clear? The degree of a non-zero constant is 0. So for example here, 3 is the degree of that is 0. The reason why, the definition says the sum of the exponents of its variables. Are there any variables in this term? No variables in the term 3. No variables, so it's to the degree 0. Okay? And of course, 0, it's a special one, has no degree. 0 has no degree. All right, so problem 1 is finding the degree of a monomial. We want to know what is the degree of each monomial. And again, remember, to find the degree of the monomial, you add up the exponents of the variables. Okay? You add the exponents of the variables. So, for 8xy, this is 8x to the first, y to the first. So the degree of this monomial is 1 plus 1, which is 2. Okay? For this one, the exponents are 4 and what? And 1. 4 and 1. So when we add those up, the degree is 5. That's all there is to it. This one, for letter C, it's 11. This one is 0. Very good. Because there are no variables that have exponents there. Okay? So why is the degree of a non-zero constant equal to 0? if I did have a variable on there, let's take 11 for example. Okay? And let's say I had an x there, 11x. What would this x have to be in order not to change the value of the 11? It had to be 1, right? So it had to be 11 times 1. What makes x, what exponent makes x equal to 1? Anything raised to the blank power is equal to 1. What blank? What's that blank? 0. So any power raised to the 0 will be equal to 1. So this is the reason why any constant, the degree is equal to 0. Got it? So the following are not polynomials. Okay? We have y to the negative 3. X to the 1/2. We have 4w squared minus 5 over w. All of those are not polynomials. The reason why the first one is why? Negative exponent. Very good. How about the second one? Why is that not a polynomial? Fractional exponent, right? What about that last one? All right, so if I rewrote this expression, it would be 4w squared over w, which is okay when I simplify that. That would just be 4w, right? But over here, this would be, if I rewrite this with no fraction, this would be, let's see, this is going to be 4w. That's okay, like we said. This, if I rewrote this w would go up, and what would happen to that exponent of a 1? It would become negative. So this is actually 5w to the negative 1. So that means negative exponent. That is not a polynomial. Is everybody clear? Variables in a polynomial cannot have fractional exponents or negative exponents. So this, negative exponent, fractional exponent, negative exponent over there. Okay? Problem 2. Let's see, is adding and subtracting monomials. You can add or subtract monomials by adding or subtracting like terms. And remember, like terms are a's, all a's, or all a squares, or all x cubes. They're all like terms. So here, these are like terms because they are x to the 4th. They are like terms if all of the exponents for the variables match. Okay? So here, we can add negative 6 plus 11, which gives me 5. And then we continue to use the x to the 4th. So that's how you add a monomial. Here we have an x squared and an x squared, y to the 4th, y to the 4th. So yes, those are like terms, and the only thing you're going to add or subtract are the coefficients. So 2 minus 7 is negative 5 x squared y to the 4th. A couple of examples that are not like terms. Let's see, not like terms. Let's see, so if I had x squared plus x cubed, okay? These are not like terms because they do not have the same exponent, okay? Those are not like terms. All right, a polynomial is a monomial or a sum of monomials. You should write this down. Standard form of a polynomial means that the degrees of its monomial terms decrease from left to right. Okay, so you have to put them in order by degree. The degree of a polynomial in one variable is the same as the degree of the monomial with the greatest exponent. So here we have a polynomial. In order for us to find the degree of this polynomial, we have to look at all of the degrees of each individual term, each one of the monomials, and then choose the highest one. And that would be the degree of the polynomial. So for this one, we can look at the degree of each of the each of the monomials. So for the first one, this is that term is a fourth degree. This term is a second degree. The next one is a first degree, and this one, the constant, is 0. Okay? So this polynomial altogether is a fourth degree polynomial. Okay? This is a fourth degree polynomial. Also, please notice that the degree of the monomials are in order by their degree from greatest to least. And that is what they mean by standard form. All right, so you can name a polynomial based on its degree or the number of monomials it contains. Okay, so a constant, that is a 0 degree. The reason it's a constant, it's called a constant because it never changes, because there's no variables in it, right? So it never changes, it's constant. There's only one term here, so that is a monomial. Okay? 5x plus 9. This is a first degree, and when you have a first degree, 5x plus 9, that is a linear expression. There are two terms, so it is a binomial. Is everybody clear? Okay, here we have 1, 2, 3 terms. That is called a trinomial. Okay. Also, if you have a squared polynomial, if your polynomial is to the degree of 2, it's a quadratic. Okay. Of course, 2x to the third power, of course, to the third means it's a cubic, right? This is just one term, so it's a monomial, right? So it can be to a degree, a higher degree, but just be one term. You see that? Here, this has 3 terms, so it's a trinomial, okay? And here, when it goes after the cubit, there are no special names for the degrees. So this is just going to be a 4th degree. Then it'll be a 5th degree, 6th degree, 11th degree, and so forth. Is everybody clear? Okay? All right, problem 3 is classifying polynomials. So we're just going to use what we just learned on the chart. Okay? Write each polynomial in standard form. What is the name of the polynomial based on its degree and its number of terms? Do we have any more in there? No, just okay. All right. So here, 1, 2, 3. 3 terms. So that is a trinomial. Very good. That is a trinomial because we have 3 terms. Okay? Now, we want to name it based on its degree. In order to name this polynomial based on its degree, we have to look at the degree of each term first. Okay? So, this first term is 2x is what degree? 1. This next one is 0, and this next one is 2. So based on the highest degree, this is a, what kind of degree? Second degree polynomial. Oh, let me write the name. Because it's a second degree polynomial, what kind of polynomial is it? This is a quadratic. Very good. Because it is a second degree. Okay. Now, I want to put the polynomial in standard form. So putting this polynomial in standard form, all that means is we put it in order from greatest to least by degree, right? So, to put this in greatest to least, the first one is 8x squared. What kind of 8x squared is that? Positive. So it's just going to be 8x squared. Then the next one is 2x. What kind of 2x is that? Positive. So I'm going to put plus 2x. And then finally, the last term is 3, and this is a negative 3, so we're going to write minus 3. And there is your trinomial in standard form. How does writing a polynomial in standard form help you name the polynomial? What do you think? Yeah.
It helps you figure out which degree it is because the greatest degree is at the very front.
Very good. It tells you, it helps you figure out the degree because the degree is in the very front because it's greatest to least. Very good. All right, problem 4 is adding polynomials. Adding polynomials. I think we've done something like this before. Okay. A nutritionist studied the U.S. consumption of carrots and celery and broccoli over a 6-year period. The nutritionist modeled the results in millions of pounds with the following polynomials. So here, for carrots and celery, we have negative 12x cubed plus 106x squared minus 241x plus 4,477. For broccoli, this trinomial represents how much broccoli was consumed. 14x squared minus 14x plus 1,545. In each polynomial, x equals 0 corresponds to the first year in the 6-year period. What polynomial models the total number of pounds in millions of carrots, celery, and broccoli consumed in the United States during the 6-year period? Okay, so the question is, what polynomial models the total number of pounds? Of course, total means we're going to add. We're going to add. Now, when you add polynomials, you need to have a column of the first type of term, a column of the second type, a column of the third, a column of the fourth, and so forth. Okay? So, in other words, you'd have, if they were all A's, B's, and C's, you'd have a column of A's, column of B's, column of C's. Okay? So, let's start with writing our first polynomial. So we have negative 12x cubed plus 106x squared minus 241x plus 4,477. Notice that each one of these terms, 3, 2, 1, and 0, okay? It's in standard form. If I were missing an x squared term, then I would put a 0x squared in there, okay? If I were missing a constant, then I would put a plus 0, okay? Because you have to have a column for every degree. So now we're going to add the second column. Here we have a 14x squared. I have to put that in the x squared column, okay? So we're going to do plus 14x squared. Then we have minus 14x. So minus 14x. And then plus 1,545. And now we can add. So now you can just add. So when we add this, down here we've got, that's 12, and then another 12, and that's 10, and then 6. Plus negative 241x plus negative 14x gives me what? Positive or negative? Negative plus a negative is a negative. Negative. So this is going to be negative 255x. Okay? See how I did that? And then over here, this is a positive plus a positive gives me a positive. Good. So that's going to be a positive. That's a 10 and a 2 and a 1. So that's going to be 120x squared. And now we just bring down the cubic. So we have a negative 12x cubed. And here is the expression that represents the total number of pounds of carrots, celery, and broccoli consumed in the 6-year period. You don't have to write this down. The two methods, okay? You could, and this is what we just did in the previous problem. So we could do it the way we did. We line up the like terms like this, right? Or we can do this horizontally. And then you just add up your like terms like this. So here, there's a cubic. Let's see, then we're going to put these like terms together. And that like term together. Then we're going to put the x term together, right? And then we're going to put the constant together, okay? So problem 5, we are subtracting polynomials, okay? Recall that subtraction means to add the opposite, right? Add the opposite. So that's that, leave it, change it, right? Remember that? The keep, change that you guys did? Okay? It's just adding the opposite, okay? So when we subtract here, when we subtract the polynomials, we're going to add the opposite of everything inside the parentheses, okay? So in essence, we're just doing a distributing, right? And what are we distributing throughout this parenthesis? A negative what? 1, right? So here, we are going to add the opposite. So we've got negative 4m cubed minus m plus 9. Does everybody see right here where there would be a 0? Okay, you leave it blank. Okay, if you want to, you could put a 0m squared in there. Okay, or you can just leave it blank. All right, so we're going to add the opposite, which means we're going to leave the first polynomial alone. The subtraction becomes addition. And everything inside the parentheses becomes the opposite. So this becomes a negative 4m squared. This becomes a negative m. And this becomes a positive 12. Let's write positive 12 like this. This becomes a positive 12. Okay? So now we add just like we did in problem 4. So 9 plus a positive 12 is a positive 21, negative m plus a negative m, negative m plus a negative m is a negative 2m, 0m squared plus a negative 4m squared is a negative 4m squared, and then we bring down the negative 4m cubed. And there you go. All right, so subtracting horizontally. Now, like I said, when you subtract another polynomial here, it's the same as distributing a negative 1 throughout the parentheses. So we will distribute that negative 1 throughout the parentheses. So we end up with negative 4m cubed minus m plus 9 minus 4m squared minus m plus 12. Does everybody see how I got that? It's like the distributive property, right? And now you just are able to combine your like terms. So here we've got just the 4m cubed, right? Let's combine them all at the same time. And then we've got, oh, we can't do that. Then we've got the negative 4m squared. So let's go ahead and just do that. So we've got negative 4m cubed minus 4m squared. And now I've got a negative m and a negative m. There is my negative 2m. There's my negative 2m. And then I've got the 9 and the 12. And here we have a plus 21. Does everybody see? We get the same thing. You got it? So you can do it either way, unless they say add or subtract horizontally or vertically. Okay?